Bismillahirrahmanirrahim. Welcome dear students. This is our physics class for grade 10 and I'm your physics teacher Yasir Mahmood. Students, our today's topic is speed of sound in air. As in our previous lecture we discussed the speed of sound in general in all the materials, but today our topic is to discuss the speed of sound in air. Actually, the speed of sound in air mainly depends upon density and elasticity of the air. So it depends upon density of air and elasticity of air. The formula to calculate the speed of sound in air is equal to square root of elastic modulus of air over density of air, and this elastic modulus is volumetric elastic modulus. Elastic modulus over density whole square root. This is the formula to calculate the speed of sound in air. So it depends mainly on two factors. One is elasticity and other one is density. Ratio of elasticity and density and then whole square root. By elasticity we means how difficult it is to change the shape or size or volume of an object. And if we check that how easy it is to change the volume of object, it means compressibility. It means that how much material is compressible. So compressibility means how easy it is to change the shape of object or size of object, and elasticity, by elasticity we means how difficult it is to change the shape or size volume of an object. So volumetric elastic modulus and compressibility are reciprocal of each other. These are inversely related to each other. These are inverse of each other. These factors like density and elasticity also changes by changing the humidity and the temperature of the air. So if we increase the temperature of air, by increasing the temperature of air, the molecules of air start vibrating fast, and due to which speed of sound increases. So by increasing temperature of air, speed of sound also increases. By increase in humidity in the air, by humidity we means presence of water vapors in the air. So as we know that air is mostly composed of oxygen and nitrogen, mostly nitrogen and oxygen, and both has density greater than water molecule. So if molecules of nitrogen or oxygen are replaced by H2O, then it means that density of the air becomes less, as O2 means 32, its atomic mass number is 32, 16, 16, 32, and this is N2. So nitrogen, atomic mass of nitrogen is 14, 14, 14, 28. अगर आप H2O की बात करें तो 2H के हो गए एंड 16 इसके, सो ये 18 हो जाएगा. सो इट मीन्स इसकी डेंसिटी जो है H2O, molecules of H2O is less dense than N2 and O2. So if in air molecules are replaced by H2O molecules, water molecules, vapor molecules, then density of air overall decreases. And if density decreases, by using this formula you can say that speed will increase. Density decrease हुई तो speed क्या होगी? Increase होगी. It means कि अगर higher level of humidity अगर एयर में मौजूद हो, वाटर वेपर ज़्यादा हो, तो उसकी डेंसिटी डिक्रीज हो जाएगी. डेंसिटी डिक्रीज होने से स्पीड क्या हो जाएगी? इंक्रीज हो जाएगी. फार्मूला टू कैलकुलेट द स्पीड ऑफ साउंड इन एयर अभी मैंने आपको बता दिया है. फार्मूला इज V इज इक्वल टू स्क्वायर रूट ऑफ इलास्टिक मॉडुलस, एंड इन एयर आर गैस इलास्टिक मॉडुलस जस्ट वन ही हम यूज़ करते हैं, दैट इज वॉल्यूमेट्रिक मॉडुलस ऑफ इलास्टिसिटी ओवर डेंसिटी. So this is simple formula to calculate the speed of sound in air. If we consider the change in temperature, then फार्मूला क्या बन जाएगा? इस फार्मूले से हम एट 0 डिग्री स्पीड ऑफ साउंड निकाल लेते हैं, और एट 0 डिग्री स्पीड ऑफ साउंड 332 राउंड अबाउट मीटर्स पर सेकंड होती है, एंड अकॉर्डिंग टू योर बुक इट इज टेकन एज 331 मीटर्स पर सेकंड. तो मैं वही लिखता हूँ जो आपकी बुक में वैल्यू की मैंने. V0 या V0 मीन्स स्पीड ऑफ साउंड एट 0 डिग्री सेंटीग्रेड. Now if we want to find the speed of sound at any temperature T, then it will be equal to speed of sound at 0 degree centigrade, that is 331 meters per second, प्लस 0.61 होता है, तो जस्ट 0.6 लिख देते हैं. आपकी बुक में भी ऐसे ही है, अप टू वन सिग्निफिकेंट फिगर. 0.6 टाइम्स राइज इन टेम्परेचर, 0.6 टाइम्स टेम्परेचर आप लिखते हैं, क्योंकि 0 पे ये लिखा हुआ है और 0 से जितना ऊपर गया वो टेम्परेचर वहाँ लिख देंगे। नॉर्मली स्मॉल टी से इस टेम्परेचर को लिख देते हैं, बट नो प्रॉब्लम। अब देखें, स्पीड ऑफ साउंड एट एनी टेम्परेचर इज इक्वल टू स्पीड ऑफ साउंड एट 0 डिग्री सेंटीग्रेड इज इक्वल टू स्पीड ऑफ साउंड एट 0 डिग्री सेंटीग्रेड प्लस 0.6 times rise in temperature. Means for every 1 degree centigrade increase in temperature, there will be increase in 0.6 meters per second, 0.6 meters per second increase in speed of sound. So at 1 degree centigrade, at 1 degree centigrade, what will be the speed of sound? So speed of sound at 1 degree centigrade is equal to V naught, means speed at 0, that is 331, plus 0.6 into 1 is 0.6, so 331.6 हो जाएगा। इसी तरह स्पीड एट अगर आप फाइंड करना चाहें, लेट्स सपोज एट 20 डिग्री सेंटीग्रेड, माइनस में भी लिख सकते हैं, एट 20 डिग्री सेंटीग्रेड करना चाहें तो ये क्या हो जाएगा, स्पीड एट 20 डिग्री सेंटीग्रेड इज इक्वल टू 331 प्लस 20 प्लस 0.6 मल्टीप्लाई बाय 20 प्लस 0.6 मल्टीप्लाई बाय 20 हो जाएगा। मैं इसको यहाँ पे लिख देता हूँ, स्पीड ऑफ साउंड एट 20 डिग्री सेंटीग्रेड इज इक्वल टू 331 प्लस 0.6 इंटू कितने डिग्री हैं, 20, जितने भी डिग्री हैं उसको 0.6 से मल्टीप्लाई करके आंसर को 331 में ऐड कर दें, उतने डिग्री पे आपको स्पीड ऑफ साउंड मिल जाएगी। तो 331 प्लस इन दोनों को मल्टीप्लाई करें, जो आंसर आता है उसको 331 में ऐड कर दें, दैट विल बी स्पीड ऑफ साउंड एट 20 डिग्री सेंटीग्रेड। सो स्पीड ऑफ साउंड एट एनी टेम्परेचर, speed of sound at any temperature will be equal to speed of sound at 0 degree centigrade, that is 331 meters per second, plus 0.6 times that temperature, value of that temperature T. So by using this formula we can find the speed of sound at any temperature. किसी भी टेम्परेचर पे स्पीड ऑफ साउंड इन एयर हम फाइंड कर सकते हैं। ठीक है, इसको आपने याद रखना है, इससे बहुत से न्यूमेरिकल्स वगैरह जो हैं वो भी सॉल्व होते हैं। सो इफ़ यू हैव टू फाइंड द स्पीड ऑफ साउंड एट, let's suppose 10 degree centigrade, then how can you find it? Speed of sound at 10 degree centigrade, you will say that speed at 10 degree centigrade will be equal to speed at 0 degree centigrade plus 0.6 multiplied by T, that is 10 degree centigrade. So speed at 0 is 331 plus, so it is 331 plus 0.6 into 10 will be 6, and it will be 337 meters per second. So you can find speed of sound at any temperature in the air. This is the formula to calculate the speed of sound at any temperature. Whether speed of sound depends on properties of wave like frequency, wavelength, etc. or not. So actually speed of sound only depends on the properties of material. Speed of sound only depend on properties of material. Properties of material. It is independent of the properties of wave. It is independent of frequency. frequency पे डिपेंड नहीं करती है. It is independent of wavelength. wavelength पे नहीं डिपेंड करती है. It is independent of loudness. It is independent of intensity. It is independent of pitch. So speed of sound is independent of the properties of the wave. Speed of sound only depends upon the properties of material like elasticity and density. So if we have two sounds of different frequencies, of different intensities, of different loudness, of different pitch, then both are traveling in the same medium at the same conditions of the medium, at same temperature, etc., at the same density, having same density of the material and elasticity of material, then speed of sound for both the waves will be same. So speed of sound doesn't depend upon the properties of the waves. ठीक है. इसी तरह एक बंदा आहिस्ता बोल रहा है, ऊंचा बोलता है, तो ऊंचा बोलने वाले की आवाज़ जल्दी नहीं पहुंचेगी. दोनों की आवाज़ सेम टाइम पे लिसनर तक पहुंचेगी अगर दोनों सेम जगह पे खड़े हैं. बट ये होगा कि एक की आवाज़ लाउड होगी और एक की आवाज़ फेंट होगी, जस्ट इतना होगा. So these are some properties on which speed of sound depends. This was our today's topic, that is speed of sound in air, and we have studied that speed of sound in air only depends on the properties of air, that is properties of material. Means if elasticity of material or density of material changes, then speed changes. If temperature changes, then speed changes. And we discussed that with the temperature, speed of sound has direct relation. Direct means this is not directly proportional relation, but if temperature increases, then speed of sound also increases. Means for every 1 degree centigrade rise in temperature, there will be increase in 0.6 meters per second in the speed of sound. So and if the density of air decreases, then speed of sound will increase in that air. As we know that by increase in humidity in the air, its density decreases, and due to decrease in density, speed in the air will increase. Speed of sound in air will increase. So by presence of more humidity, or by presence of more humidity in the air, speed of sound will increase in the air. And if we have dry air as compared to humid air, if we have dry air, then in the dry air presence of humidity is less, means it will be more dense as compared to humid air, and due to which speed of sound will be less in the dry air. So speed of sound in dry air is less as compared to the speed of sound in humid air, and it is due to change in the density of the air. So this was our today's topic. Revise the topic, write it down on your neat notebooks. If you have any problems, you may ask. Thank you.